Number 20. Fill in the lone pairs needed to give the main group elements, except hydrogen, an octet. So here are two molecules, and you're given most of the Lewis structure for both of these, and you're asked to finish it by filling in the lone pairs. And when you do that, you're going to be giving the atoms octets. And it tells us a little bit about these molecules. Glycerol is a product of the metabolism of fats. So this is like your building block for lipid molecules. What happens is this glycerol molecule has the capability to attach 3 fatty acid molecules, and they attach here on to the oxygen. So you have one attached here, one attached here, and one attached here, and that's basically your fat molecule. Okay, this is just the building block for fat molecules. And when fat is broken down, you get this molecule back. So it's a product of the metabolism of fats. Acrylamide is used to make polyacrylamide, which is used in cosmetics and food packaging. Polyacrylamide is basically a polymer of this molecule. If you can attach this molecule to itself over and over and over again, so imagine a bunch of acrylamide molecules attached together, and that's what a polymer is. And you can form polymers from many different types of molecules. So if you form it from this one, you'll call it polyacrylamide. If you form polymers from ethylene, you call it polyethylene, and so on and so forth. And from amino acids, that would be a polyamino acid, polypeptide, which are basically proteins. And anyway, I don't know much about polyacrylamide except that it's a bunch of these molecules attached together. Okay, anyway, you're asked to complete the Lewis structures for these two by putting in lone pairs and to give octets to the main group elements, okay, except hydrogen. So let's talk about that, and then we'll do this problem. So the way you do Lewis structures, I hope you watched the lecture video, but if not, I'll give you a quick tutorial. You need to know how many valence electrons each atom has. Okay, hydrogen is in group 1A, and you can find hydrogen right here. It's in group 1A, so it has one valence electron, and it likes to form one bond. Okay, if you look at all of the hydrogens in these molecules, they all have one bond. So they're all bonded to one other atom through a single bond. This one, they all look like that in this molecule as well. You will never see hydrogen with 2 bonds, okay, that looks like this. You cannot have hydrogen bonded to 2 other atoms at the same time. It's always just one bond. It's always attached to the exterior of the molecule, and so all of these hydrogens are good. Okay, they all look like that. Now we're only really interested in the atoms that are in these molecules, but just to finish this little tutorial, moving down the list, beryllium is in group 2A, and all of these atoms in group 2A have 2 valence electrons. They can form 2 bonds. Boron is in group 3A. You skip over these B elements. Boron's in group 3A. It has 3 valence electrons. It can form 3 bonds. Carbon is in group 4A. It has 4 valence electrons. It can form 4 bonds. Now these can be 4 single bonds, maybe 2 singles and a double, maybe 2 doubles, or maybe a triple and a single. So there's multiple ways in which carbon can do this. Okay, now notice that when carbon does this, okay, by forming these bonds to other atoms, what's actually going on here? If you're looking at, say, this one, is these bonds are really electron pairs that are being shared. So I'll kind of draw in the electrons. Okay, so that's what a covalent bond is. It's a pair of electrons that are shared between carbon and the other atoms. So by doing this, carbon gets an octet. Okay, by itself, before it forms these bonds, it only has 4 electrons around it. But after it forms bonds with other atoms, it now has an octet. So 2, 4, 6, 8 electrons around it. So carbon's got an octet. And there are multiple ways that carbon can do this. It can do it like that too. So all of these involve carbon having an octet. Okay, and that's what this is talking about in the problem. Sometimes lone pairs are involved, and you'll see that with nitrogen and oxygen. But before we move on to nitrogen and oxygen, let's just take a look at all of the carbons in these molecules over here to the left, okay, to make sure that they are okay. Now looking at this carbon, let's zoom in a little bit on acrylamide. Looking at this one, this carbon looks like it has 2 singles and a double to the oxygen. 2 singles and a double. And that looks like that form of carbon. Okay, so that's good. All of these are what carbon, typically bonds like. Okay, and they all have octets. I kind of drew in the electrons and showed you the octet here, but there's also an octet there as well. And if you wanted to, you could, draw in the electrons. Normally you don't do this, but you can count them all up. 4 bonds means an octet. Okay, they're all octets. Okay, and so this carbon, this carbon looks like that. So this one is good. 2 singles and a double. This carbon also has 2 singles and a double. Okay, so that one's also good. This carbon has 2 singles and a double. So they all look like this form over here. Okay, so all of those carbons are good. We check the hydrogens, they're good, and the carbons are good. We'll take a look at oxygen and nitrogen in a second, but let's check the carbons over here. Over here, all of the carbons have 4 single bonds. This carbon, 1, 2, 3, 4 single bonds. So that carbon is good. This one's good, and that one's good. So all of these carbons have 4 single bonds. They all look like that. They have their octet. Now, let's move on to nitrogen. Nitrogen is in group 5A. It has 5 valence electrons. 1, 2, 3, 4. You go back and pair it, 5. So since these are paired, they are not going to form a bond. So nitrogen, you're back down to 3 bonds. They can be 3 singles, or maybe a single and a double, or maybe a triple. Okay, but the nitrogens, will look like this most of the time, and 99% of the time you'll see nitrogens looking like this and carbons looking like that. There are exceptions, especially when you draw Lewis structures for polyatomic ions, but 99% of the time the carbons and the nitrogens will look like this and the oxygens will look like that. Okay, so it looks like there are no nitrogens over here, so let's check the nitrogen over there. So nitrogen over there, we see 3 singles, and it's missing its lone pair. So let's put that lone pair in. Okay, putting the lone pair in makes the nitrogen look like this right here form. Okay, it's not one of those. It's like this, and that is an octet. So you can see, the 2 electrons, and then each bond has 2. So 2 plus 4 plus 2 is 6 and 8. 2, 4, 6, 8. So by giving that the lone pair, this nitrogen now has an octet. Okay, and let's keep going down this list. Oxygen is in group 6A, so 6 valence electrons. You know, 1, 2, 3, 4. You go back and pair it, 5 and 6. It doesn't matter which sides are paired. There are 2 unpaired electrons, and so oxygen can form 2 bonds. It could be 2 singles or a double. You know, and going here to the acrylamide, you see that this oxygen has a double. So it's going to be that form. Okay, either one, oxygen needs 2 lone pairs, but this is what this oxygen looks like. So we need to add in those 2 lone pairs. And doing that, we have addressed all of the atoms here. They are all good. The Lewis structure for acrylamide is complete. Now let's go over to the glycerol. The glycerol, we've already checked the carbons and the hydrogens. We just got to check the oxygens now. The oxygens, they all have 2 single bonds. Okay, so it looks like this form. Okay, now no matter which form oxygen, it's going to get, you know, 2 lone pairs. So, you know, it doesn't have its octet yet. We got to give it the lone pairs. So there you go. Now it's got its octet. So that's 2, 4, then the bonds 6, 8. Okay, do the same thing for the other oxygens. Okay, giving them the 2 lone pairs gives it an octet, and same thing over here. And now the glycerol is done. And that's how you do this. Okay, I know we didn't get to, you know, the fluorines, but you should memorize how to do this, and at the very least memorize the main group elements, the big 4: hydrogen, carbon, nitrogen, and oxygen. Okay, now hydrogen doesn't get an octet. Okay, but the other ones do. So the carbons and the nitrogens, the oxygens, you should memorize what the bonding patterns for these guys look like. 99% of the time, that's what the bonding patterns look like. You know, the 1% where you'll see something different, it usually involves a polyatomic ion. Okay, and sometimes, you know, every once in a while you'll see, so I'll give you an example. Every once in a while for nitrogen, you might see something like this. Nitrogen has 4 bonds. Okay, but that's rare. You know, most of the time nitrogen will look like this. But even if it does have 4 bonds, it still has an octet. And same thing with oxygen. Most of the time oxygen is going to take one of these forms, but sometimes you will see oxygen with 3 single bonds, and, you know, maybe like that. More often you might see oxygen look like this, maybe 3 lone pairs and a single. Okay, either one, it still has an octet, but 99% of the time oxygen is going to take one of those forms. Okay, you know, just be aware that you will see some other forms sometimes.